I am T. Arun Kumar, Assistant Professor of Mathematics, Department of Science and Humanities, Hindustan College of Engineering and Technology, Coimbatore. Now we will discuss the topic Principle of Mathematical Induction. First we will discuss mathematical induction. Mathematical induction is a concept that helps to prove mathematical results and theorems for all natural numbers. The principle of mathematical induction is a specific technique that is used to prove certain statements in algebra which are formulated in terms of n, where n is a natural number. For that, let us consider an example. 2 plus 4 plus 6 plus etc. plus 2n is equal to n into n plus 1. Here we are considering a series sum of first n positive even integers with n is a natural number. We need to prove this above statement is true for n is equal to 1 and n is equal to 2 and n is equal to 3 and so on. In order to check the validity of the formula for each term, we need a domino effect. In domino effect, we need to show that the formula is true for the first term, then the formula is true for the second term, and so on. Domino effect means first we use the dominoes one after other. Our goal is all the dominoes will fall. The best way to achieve our goal is condition 1. When the first domino falls, it will hit the second one. And condition 2 is make sure that each domino will hit the next one and each domino that is hit will fall. If the two conditions are satisfied, then our goal is true. That means all the dominoes will fall. Similarly, in mathematics, to prove the formula is true, it has to fulfill the two conditions. So the first condition is a base case and the second one is an inductive case. So in condition 1, we need to first prove P of 1 is true. That is for n equal to 1. So here n is equal to 1 means first term. Here this P denotes the proportional statement. For example, we can consider a statement x is cold. The statement is x is cold. And P of x is true or false, which depends on x. If x is ice, then the statement P of x is true. If x is fire, then the statement P of x is false. And second condition is the inductive case. So condition 2, if P of n is true for n is equal to k, then P of n is true for n equal to k plus 1 also. We need to assume P of k is true and we need to prove P of k plus 1 is true. If the statement is true for P of k, then the statement is true for P of k plus 1 is true. That is called inductive hypothesis. Let us solve one example. For that we are considering a series 2 plus 4 plus 6 plus etc. plus 2n is equal to n into n plus 1. Here we are taking P of n as the given series 2 plus 4 plus 6 plus etc. plus 2n equal to n into n plus 1. We need to prove first condition 1. The condition 1 is P of 1 is true for n equal to 1. So n equal to 1 means first term. Here there are two sides, left hand side and right hand side. We need to prove both left hand side and right hand side are equal. First we will prove left hand side for P of n. So in condition 1 we need to prove P of 1 is true. So P of 1 on left hand side is the first term is 2. So P of 1 value on the left hand side is 2. And P of 1 on right hand side is, we need to substitute n is equal to 1 in right hand side of the equation. If n is equal to 1 means 1 multiplied by 1 plus 1. That becomes 1 into 2 becomes 2. Hence the left hand side and the right hand side of the above statement is equal. Therefore, the first condition is true. And next we will move to the second condition. Second condition is we need to assume P of k is true. So for that we are taking P of k value. So P of k becomes 2 plus 4 plus 6 plus etc. plus 2k is equal to k into k plus 1. So here we need to assume P of k is true, then we need to prove P of k plus 1 is also true. So first we will take left hand side and right hand side here. So P of k plus 1 for the left hand side becomes 2 plus 4 plus 6 plus etc. plus 2k plus 2 into k plus 1. So for this first 2k terms, 2 plus 4 plus 6 plus etc. 2k, the value of this one is, we assumed already, that is k into k plus 1. So here we need to substitute this 2 plus 4 plus 6 plus etc. 2k is equal to k into k plus 1. So it becomes k into k plus 1 plus 2 into k plus 1. So from these two terms, if you take k plus 1 common out, means we get here in first term we get k, in second term we get plus 2. So left hand side value becomes k plus 1 into k plus 2. And right hand side becomes, here right hand side is k into k plus 1. So here we need to replace k by k plus 1. So if k is replaced by k plus 1, here means k plus 1. Here it is replaced by k plus 1 means k plus 1 plus 1. And k plus 1 into k plus 1 plus 1 becomes k plus 2. So right hand side of the above statement for k plus 1 is k plus 1 into k plus 2. Therefore left hand side and right hand side is equal. Therefore the above statement is true for all natural numbers. This is the inductive proof of is now completed. Therefore, by the principle of mathematical induction, P of n is equal to 2 plus 4 plus 6 plus etc. plus 2n is equal to n into n plus 1 is true for all natural numbers. Thank you.